Mr. Fritz here, and we're going to talk about inverse functions. And let's just jump right into it. Hopefully you've seen some stuff from in your previous algebra days about inverse functions. And I want to show you a good example of what inverse function looks like. So I want to think about packing something and sending it in the mail. Perhaps an Xbox we can send into the mail. Now let's think about what we're actually going to do. If I want to send this in a package, you can't just stick an Xbox in a mailbox. You got to do some stuff to it first. You probably want to wrap it in bubble wrap. You should probably put it inside of a box. Then you want to close the box, and then you want to pack it up. Well, you send that thing in the mail, it arrives, and then you get a package. And what if we wanted to reverse this process? Now I want to get at the actual thing that's inside of this package. I want to get after the X box. And what I can do then is I first will probably have to remove the packing tape. And then I'll open the box up. I'll take the X box out and then remove the bubble wrap. And now I get to enjoy the X box. And really what you can tell from this is that I've just kind of like undone this process. First, I packed all that stuff together, and then I unpacked everything kind of like in a reverse process. And what happens when I perform one process and then the reverse process in reverse order, what I kind of left with is the X box. And so if we keep that in mind about these processes undoing each other in reverse order, that's kind of exactly what we're thinking about when we think about functions and inverse functions in math. We can talk about inverses mathematically. If I have a map of inputs and outputs, let's say I've got inputs 1, 2, and 3, and I've got outputs 4, 5, and 6, we would say that the function f of x could map my inputs to my outputs. So if I put an x value into my function f of x, I would get an output value. What an inverse function is basically going the opposite direction. Now I'm kind of starting with an output, and I am working my way towards an input. So we call this the inverse function. And we'll get into this notation in a second, but basically the idea is that it undoes, this rule is undoing whatever this rule did. So where I used to go from an x to a y, now it's like I'm going from this thing to this thing. So let's talk a little bit more about this. Notation. Function notation, we're familiar with this. If you see f of x, that means we have a function. It's called f. The input is x. If I wanted to talk about an inverse function, I can specify that this function here is the inverse of the function f. So it's important that I'm using f here because it's referring back to that original function. This literally means is the inverse function of f of x. We could say f inverse of x. Now note, this inverse does not mean to the negative first power. Do not confuse this with 1 over f of x. That's completely different. What this is equal to is 1 over f of x. Really, that's the same thing as f of x, that whole thing raised to the negative first power. So this negative first power as an exponent is different than putting that negative 1 before this parameter x. So this would be f inverse of x, not the same as this thing. Don't get it twisted. And then finally, this inverse function identity. This is a little bit of a definition here. If we have two functions, we say that they are inverses of each other if their composition function is equal to x. What do I mean by that? Think about the packing and unpacking of the x box. If I compose a function or a process inside of another process, and what I get out is the original thing that I put in, those things are inverses. So the process of packing up the x box and unpacking up the x box, those were inverses of each other because once you do the thing and then undo the thing, you're left with the original input, the x box. So this is just an important identity. If I compose these functions, then they are inverses if I get out an x after making this composition. All right, so let's keep going forward with this, and let's talk about switching x's and y's. Really, what inverses do is they switch all the x values with all the y values. Let's think that I have this. Let's consider this function I have here, and you can see this in this animation that I've made. We're kind of starting off with some xy graph where x is the time and y is the money, and it could represent all kinds of things. But if I wanted to change up my function so that now I'm not solving for money, but now I want to solve for time, I have to switch for my x's and y's. So we like this kind of a graph if I wanted to say, well, how much money would I make after a certain amount of time? And what I might like this graph for is if I were to say, okay, I want a certain amount of money, and how much time will that take? So I want you to kind of wrap your mind around what's going on here. I switch my x's and my y's when I find an inverse of a function, since I'm kind of working my way back or tracing my steps back to how I got there with my original function. All right, so let's kind of move forward away from this animation here, and let's talk about reflections of these graphs and their inverses. So what you might notice and what you might remember is that all inverse functions, they reflect over the line y equals x. And if you take a look at all these coordinates, really all that I'm doing here is I'm swapping out my x for my y and my y for the x. So we can say that functions and their inverse, they reflect over the line y equals x. And hopefully that makes sense. If x's and y's switch, then they should reflect over the line where they are all the same. And in general, if I have some coordinate on a function x comma y, then I will find the reverse coordinate y comma x on the inverse function. And I think this is kind of confusing because we see y comma x and we think, wait, but I thought it's always x comma y. And like it is, a coordinate is the x position and the y position. So I think maybe an easier way to think of this would be actually instead, let's go with red. If I take some value a and f of a, so this would be like an x value and a y value evaluated for some a. A could be any number. Then what the inverse coordinate would have is f of a, comma a. And what I've done here is this is how I can kind of show that what used to be my output is now my input, and what used to be my input is now my output. So I've actually switched the roles in an inverse function. And you can kind of verify that with this picture I have right here. So we're going to do some more stuff with inverses and in the next video. So make sure you check out that next one.